This lesson, once again, is nothing that is all that new because we were doing sketching parabolas as part of the functions topic. And you were sketching parabolas back then. Yes, Mark?
What page is it?
What page? It would be on page 3 or 4, I think. Sorry, there's no page numbers. Thank you. Do we all have that now? Great. Okay. Let me just take you through the 5 steps again. So step 1 was concave up or concave down. We've done that before. Step 2, so we've got step 1 for sketching parabolas. Step 1 is it concave up, concave down? Concave up or down? Let's just remind ourselves. Can anybody remember when is it concave up?
Positive.
Good. When the coefficient of x squared is positive, it's concave up. And then, of course, the opposite works. The coefficient of x squared is negative, it's concave down. Okay, second step when we are doing this is find the y-intercept. Y-intercept. The y-intercept is when x is 0. So x equals 0, find that. Step 3 is find the x-intercepts. Find the x-intercepts. Now, following on from last class, we had a special name for the x-intercepts and we called them the roots. So, which are the roots? Finding the roots. And to do that, we had 2 ways to do it. The first way was that we could factorize out and solve. And the second way was to use the quadratic formula. So that was that. Step 4, determine the axis of symmetry. So, find axis of symmetry. And lastly, we want to find the minimum or maximum point. So, find min or max, which is the vertex. So, once you have that, we can work it out. By the way, the axis of symmetry is minus a on 2b. That is your formula to find it.
Isn't it minus down to a?
Oh, thank you. I did muddle them up. Thank you so much. Great. I love it. I love it when people pick me out fast because it tells me that you're listening and you're paying attention, which is great. Okay. If you want to look, you might be wondering where on earth does that come from? If you have a look over the page, the proof is over the page. It does come from your quadratic formula. So basically, the plus or the minus square root b squared minus 4ac, that tells you how far away, but the bit that stays the same all the time is your minus b on 2a. So that is the central point. And then the minus, then the square root for b squared minus 4ac and plus, yes.
Do you need to memorize this proof?
You don't need to memorize the proof. No. All you need to know, so Cody, the only thing you need to know is you just need to know to use that. That's all. Okay, so because of that, this turning point or the minimum maximum point, the x value is going to be this exactly. Because that axis of symmetry gives you an x value. and it gives you that dotted line x. We've done that in previous classes. Do we remember how to find the y value?
Yes, you put it back in.
You just put it into, yes, put that x value, whatever that is, back in to the equation. We find the y value and you have your minimum and maximum point. So none of that should be new to you. Okay, so let's do our examples. First one says sketch y equals x squared minus 2x minus 8. Okay, firstly, we know, first step, is it concave up or down? Concave up, because that's positive. So, concave up. Good. Next step, we want to find the y-intercept. The y-intercept is where x is 0. So if x is 0, y-intercept is?
1 equals 8.
You've got it. Equals minus 8. 3. We've got to find the x-intercepts. Well, can we factorize it? Is there any numbers that
2
times to give us minus 8 and add to give minus 2?
minus 4.
They sure are. So we could have 0 equals, because x-intercept is when y is 0. So that equals x minus 4 and x plus 2. So what are the x values? The x values that make this equation work is 4 and minus 2. X equals 4 and minus 2. So I've done the first 3 steps here. Step 4, finding the axis of symmetry. Okay, finding the axis of symmetry. Well, I have my B and I have A is going to be 1. So the axis of symmetry equals minus B. Well, if B is already minus 2, so that's going to be plus 2 over 2 times 1, which is 2. So the axis of symmetry is going to be 1. Step 5. Now I need to find the minimum or maximum point. Okay, so the x value is clearly 1. Now to find the y value, I need to put it back into this. So I'll just make a little note here. Y equals 1 squared minus 2 times 1 minus 8. 1 squared minus 2 is?
2. Oh, 1.
Minus 1 minus another 8. It's going to be minus 9. Now, is that going to be a minimum or a maximum point? Well, if it's concave up, it's going to be a minimum, because concave up has a minimum point, whereas concave down has a maximum point. So this is going to be my minimum point. And I'm going to abbreviate. You don't need to number them 1, 2, 3, 4, 5. I've done that just to make sure that we don't miss out any steps. But I want, when you are doing this, to make sure that you follow these steps exactly and then sketch. To get full marks for this question, you need to show that you've gone through this whole process. So now it comes time just to sketch it. Y, X. One thing I want you to do when you're sketching, please make sure you do draw your arrows, do write your X and Y. Okay, so it passes through Y at minus 8. So 1, 2, 4, 5, 6, 7, 8. So it passes through at minus 8. That's minus 8, I'll just mark it there. And it passes through X at minus 2 and 4. 1, 2, 3, 4. So it passes through at those 2 points. Okay, so I've got that. I also know my axis of symmetry is 1. So I'll just do my dotted axis of symmetry. My minimum is 1 minus 9. So there's my minimum. So that means I now have everything I need to sketch it. Please label it. So y equals x squared minus 2x minus 8. Okay, and this point here is -2, 4. My axis of symmetry of this line is x equals 1. And my minimum point here is 1 minus 9. You want all those details to be very clear. I was at a professional development day, and a man who has often been part of HSC marking was talking to us. And there can be debates amongst the HSC markers whether or not to penalise you if you don't label your axes X and Y, or if you don't draw arrows and things like this. What happens if you forget?
So what happens if you don't write the equation?
If you don't write the equation, well look, probably most of these things they are lenient in, but there are years where they can be tough on. What I'm saying is, we're not going to know 100% what things they might penalise you for, but these are all the things to get. If you do this, you will be guaranteed full marks. And I don't want you to take shortcuts, because it would be such a disappointment if you get there, you know how to do it, but you've just taken a couple of shortcuts, haven't done a couple of things, and then you do get penalised marks you could have got. So as we go through this, I'm going to get you to practice doing it in full. Any questions about that? Any questions? No? Let's do the next one. Can I rub it all off?
Oh, yes.
Yep. Great. Okay. So question 2 says sketch a y equals x squared minus 6x plus 9. Okay. This time I'm not going to label it 1, 2, 3, 4, 5, but I'm going to follow that system. Okay? If you think you're liable to forget one of the steps, feel free to write in the numbers. So the first thing is it concave up or down? We know it's concave up. Concave up. Let's see, we want to find the y-intercept. So y-intercept, so y equals 0 squared minus 6, 0 plus 9, so equals 9. Done. The x-intercepts. Well, can we think of two numbers that multiply to give 9 and add to give minus 6? What would they be? Minus 3 and minus 3. Okay. So x-intercept. So we know that it's when y is 0. So 0 equals x minus 3. Huh. How many roots does this have?
1.
1. It only has one root this time, x. So the x equals 3. Okay. So found the x-intercept, so now I need to find the axis of symmetry. Axis of symmetry, which is minus b on 2a. So equals minus b, which is 6 on 2a, which is 2. So axis of symmetry is 3. Huh, same as your x-intercept. Find the minimum or maximum point. Well, is it going to be a minimum or a maximum? What do you think? If it's concave up, it's going to be a minimum. So the minimum, why? Since it is concave up. And that is 3. And we put 3 into this. So y equals 3 squared minus 6 times 3 plus 9. So we have 9 minus 18 minus 9 plus 9 is 0. Okay, I have everything I need to do my sketch. So, draw your lines. put your arrows on. Label it X and Y. Okay. It's concave up. We know that. The y-intercept, it crosses y at 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. X-intercept is 3. 1, 2, 3. There I have my x-intercept. It only crosses once. Hang on, if it only crosses once, that must mean that it just touches. Because if it crosses, it has to cross somewhere else. So if there's only one root, it touches there. And the axis of symmetry is x equals 3. And the minimum is that point 2. Okay. I'm ready to go. So it looks like that. I need to write that that's 9. This point right here is 3, 0. That's 3. This line is y equals x squared minus 6x plus 9. And the axis of symmetry here is x equals 3. I've written everything on there, made it 100% clear. Any questions about that one? Fairly straightforward. We've done this before, right? Just give you a moment to copy that down. Then we'll do example 3. After example 3, we do have one new thing we will do today. And this new thing is going to be very important, especially to those in Maths Extension 1 at the moment, because I believe that it will help you. It will help you discriminate. It will help you with solving some of the stuff that you're doing at the moment.
I tried using that, but I didn't know how to do it.
But you didn't know what the discriminant was?
No, we did it last year.
Okay.
What is it?
That's not a show.
Are we ready for example 3?
Oh, yes.
Yes. Let's do it. One more. Oh my god, they're lying to me. Okay. So example 3, the question says sketch. And this time it's y equals 2x minus x squared minus 5. What do you notice about the order that this has been written in?
It's wrong.
It's wrong! Okay, so what it is, it doesn't have x squared first. So we're going to just need to watch out. Okay, are we concave up? Concave down. Good. Concave down. Because the coefficient of x squared is minus 1. Yes. I could. So if you wanted, that's a really good question. In fact, I recommend it. Just so you don't make a mistake later on. It'd be a great idea to rearrange it earlier in the piece. Okay, so now we want to find the y-intercept. Y-intercept. So you let x equals 0. So y equals 2 times by 0 minus 0 squared minus 5. Okay, that is minus 5. The x-intercept. Now, can we think of any? No.
Yes.
It's a bit hard, isn't it?
Yeah.
No, we.
Well, what do we need to use? Quadratic formula. We're going to do it. So x equals.
Just use that little the square roots work as a negative form to find if there's solutions or not.
You're jumping ahead to the discriminant. We're going to get there.
Jeez.
Okay, minus b, so minus 2, plus minus. square root of, sorry, the square of b minus 4 times by a, which is minus 1 times by c, all over 2a. Okay, that's minus 2 plus minus. Okay, this part here, that's 4 minus 20, minus 16. What do you know? There are no real roots. No real roots. Okay, so last time when we did sketching parabolas in the previous topic, were there any examples that you did or any questions that had no real roots? No. You only had ones that worked before. What do you think it means to have no real roots when it comes to sketching? It's not crossing the x-axis. So, we know that it doesn't cross it. Well, what's the next thing I do? I now need to find axis of symmetry. The axis of symmetry, which is minus b minus 2 over 2a, so that's minus 2, so equals 1. So I know what the axis of symmetry is, and I can work out the, hang on, is this going to be a minimum or a maximum this time? Max, because it's concave down. So max, the maximum, because it is concave down. Is 1, and on the side, let's just work it out. So minus 1 squared plus 2 times 1 minus 5. So that's minus 1 plus 2, which is 1. That's minus 4. So my maximum is 1 minus 4. Now let's draw it. So have y, x, put on your arrows, put on your x, y. Okay, I know it crosses y at minus 5. 1, 2, 3, 4, 5. So I know it crosses y there. I know my, x-intercept. There's nothing. I can't do anything. But axis of symmetry is 1. So at 1. Okay, and I know that the minimum point is 1. Sorry, maximum, yes, thank you. 1 and minus 4. So that's all I have to go off. What's going to look like that. So y equals 2x minus x squared minus 5. My maximum point here is 1 minus 4. Crosses there at minus 5. This axis of symmetry, x equals 1. And there I have it. That makes sense? Yeah? Okay. So, we'll just rub out this side, and we are going to talk a little bit today about the discriminant. Basically, your discriminant is a shorthand way, rather than going through all of this to work out that there are no real roots. The discriminant is a shorthand way. So, first of all, let's just think about the word discriminate. Can you maybe put it into your dictionary on your computer? Or just use your knowledge of the word. What does discriminate mean?
Discriminate means to.
Means thing we don't like.
Yeah, we don't like it when we discriminate against people. Yeah.
We ain't that.
I'll just wait till anyone finds the definition, and then I'll tell you the definition I'm going to go with.
What do you know?
Any ideas first? So my definition is to note or observe a difference. Okay, so definition of discriminate. Okay, let's think about it. Why do we discriminate? What are the examples? Oh, this person is a different nationality. Maybe they're Middle Eastern. So we treat them differently because of a difference. Maybe people are discriminated on religious grounds. So they see that there's a difference between... We're noticing a difference between what this person holds and what maybe the other people hold, what views they hold. We see there's a difference, and then when they're discriminated against, they're treated differently because of a difference. It could be a difference in nationality, could be a difference in religion, difference in gender, all these different areas, but it's observing a difference and then it's often treating them differently because of that, which obviously isn't fair. But rather than working out the whole thing, Jared pointed out something really interesting before. Jared, what part of the quadratic formula tells us whether there are two roots, one root, or no roots?
Whether the discriminant is positive, 0, or negative.
Okay, so whether it's positive, 0, or negative. So, let me write the quadratic formula out. Plus minus b squared minus 4ac over 2a. This part here is the part that discriminates or shows the difference between whether there is one root, two roots, or no root. Okay, how? If it's 0, as he said before, if it's 0, it's only going to be one root. It's just going to be minus b over 2a. If you've come up with two answers, there's obviously going to be two roots. If this is a positive number, if it's negative, there are no real roots, and hence we say that it doesn't have any roots. So, what we say the discriminant is your b squared minus 4ac. Now, discriminate starts with the letter D. Because of that, and because in maths we use a lot of Greek letters, we're going to use the capital letter D in Greek, which is delta, and capital D, capital delta, is the triangle. So delta equals b squared minus 4ac. And that is our discriminant. So let's do, can you turn your page over and let's find the discriminant of these questions. So just rub this out quickly. Okay, so the first one, find the discriminant of 4x squared minus 4x plus 1 equals 0. So the question says find the discriminant. Are we all ready? Okay, so find the discriminant of this. So what we're doing is you're doing this. The discriminant is b squared minus 4ac. B squared, which is minus 4 squared minus 4a is 4, c is 1. Okay, so this is 16. 16 minus 16, which is? The discriminant of this one is 0. Great. Second one is 3x squared minus 5x plus 5 equals 0. Same thing, discriminant, capital D, capital delta, is b squared minus 4ac. What's b in this case? Well, this is a, b, c minus 5. So minus 5 squared minus 4 times 3 times 5. So, minus 5 squared, that's 25, minus 12 times, that's minus 60. Okay, what's 25 minus 60? We've got minus 35. So this time my discriminant is negative. Okay, I'm not going to project it on the board because you have it in front of you and also makes it hard for the video. But this page here shows you if we have no real roots, we've already said that it means that it doesn't cross the x-axis. So if the discriminant, if that part is less than 0, then this is what the graph is going to look like. Hopefully you have it there in front of you. Okay? Do we all have it there, or do you want me to write it up on the board? Yeah? Sure. I'll do that. So if delta, which is our discriminant, is less than 0, we know that there is no real roots, and hence the graph looks like that, or it looks like that. In other words, it doesn't cross the x-axis. Okay, if delta equals 0, there is 2 real but equal roots. Which is the same as saying really just one root because they are equal. Okay? Which means it touches. So it's going to look something like that. Or, okay? And if it is greater than 0, it has 2 real unequal roots, which means it crosses twice. It's going to be like that, or like that. Okay? Any questions about that? It has one other point here. If delta, so if your discriminant is a perfect square, then you're going to get rational roots, whole numbers. If the discriminant is not a perfect square, you're going to get irrational roots. We did some of these last time. You know, it could be 3 minus root 2 and 3 plus root 2. Okay, so that's if your discriminant is perfect square or not. Okay, so the last 3 examples we're going to do before the bell goes, we're going to find the discriminant and use the discriminant to find whether the roots of the quadratic equations are real or unreal, rational, equal or unequal. So we're going to look at what are the roots based on the discriminant. So example 1. So I have 4x squared minus 12x plus 9 equals 0. So my discriminant, b squared minus 4ac, b squared, so we have minus 12 squared minus 4, 9, b squared, we've got 144. 16 times 9 is once again 144. Okay, so we've just shown that the discriminant is 0. Brian, what does that mean?
It means that no other be 1.
Yeah? So roots are, they're real roots. Yeah. And they're going to be rational or irrational.
Rational.
So therefore, we can say roots are real, they are equal, and because they are equal, we can technically say, as you said, Brian, one root, and rational. And we've used the discriminant to help us. Number 2. Number 2. So 4x squared plus 11x minus 3 equals 0. Find the discriminant, so I have b squared minus 4ac. b squared, so you have 11 squared minus 4 times 4, that's minus 3. So that is 121. That's going to be 12 times so this plus 12 times 4 is 48. Yeah. So 48, we have 169. Is 169 a perfect square or not?
Yes.
Yes.
Yes. What does that tell me then? What can you tell me about the roots? Roots are what? Are they real?
Yes.
Yes.
Yes. Are they equal?
Yeah.
No. Because they're only equal if it's 0. So there's 2 separate different ones. Are they rational? Are they rational?
Yes.
Why?
The whole number.
Because it's a perfect square. So roots are real, rational, but not equal.
So you can't just say there's 2 roots, you just say all that and one of it.
Yeah, you can say that. Because they specifically asked us the question, says to say whether they're real or unreal, rational or equal or unequal. Okay, last one. Question 3. So, question 3, 4x squared plus 3x plus 1 equals 0. So the discriminant, b squared, so 3 squared, minus 4, a is 4, c is 1. So 9 minus 8. What do I do? Minus 16 here. So you have. Okay, what can you tell me about the roots?
No roots.
No real roots. Okay, so roots are not real.
Yeah.
That's if their roots are not real because you don't know anything. Well, aren't meant to know anything yet about unreal numbers or imaginary numbers. You don't need to say anymore. As soon as they're not real, you just say they're not real. Don't comment any further. Are you done?